So we're live streaming, and today I'm, pardon me, I need to context switch in here. I'm just back from the weekend in Fosdem, and I really needed to flush out some thoughts in a blog entry. The live streaming is really cool because with live streaming you can kind of think aloud. It doesn't take anything away. You don't have to stop and organize everything that you're doing. You can just kind of like flow it out. But if you only do things on a live stream, of course, then it's pretty hard to keep track of. So I need to occasionally kind of slow down and summarize things, and that's what I did this morning by just blogging a little bit about some Snabb device driver work. So now I'm hopping in a little bit unprepared on my live stream. But the topic today is I want to make the Studio development tools easy to install on a Mac. And Studio is a Linux application, but it's development tools. So of course, a lot of people are going to want to run it locally on their own machine, and a lot of people are going to have a machine that's not natively running Linux. So what I want to do is just have a really simple way to get a Linux base layer to run Studio on, even if you're not on a Linux box. And the simplest way that I can think of to do that is with Docker. So all I really want to do is make a Dockerfile so that you can quickly get an environment up and running on a Mac, which is then compatible with the normal Nix-based installation setup for Studio. So that's all I really want to do now, is write such a Docker file and get such a Docker image so that we can make a Mac variant of the installation steps for Studio. So let's hop in. Let's write a to-do list and all of the things that we usually do. Pardon me, swapping everything back in. Over here and over here. Here we have an empty to-do list. So we're gonna draft a Docker file, build a Docker image, and we're going to test Studio, let's say debug, because I'm sure it won't work the first time. Studio installation, and we're going to push the Docker image to Docker Hub. That would be nice, wouldn't it? If we would get all of those things done, then it would be really easy to get Studio running on the Mac. You'd install Docker, and you'd just tell Docker to run this image. We'll make it the last step. Write down the steps to install it on a Mac. Okay, let's see how we go. And we'll update our little status line at the bottom. Great. Now it says that our goal in blue is to draft a Docker file. And I actually already did this. I already did this on a plane ride over the weekend. I have a Docker file that probably isn't quite right, but that exists anyway. So let's start from that. So now I'm going to not SSH into the Linux box that I usually work on. I've got to stay on the host here, which is a Mac desktop, and I'll grab this Docker file. Let's just get a base Studio directory. We may as well do the Docker file there, because that's where we're going to want to check it in the end. So here's our starting point. We have a Docker file that begins with nixos/nix image. We're going to take a look at that. That's just a really basic image that's Alpine Linux with Nix installed, and then we get any other things that we might want to have that are handy. In this case, I thought Git, because it's probably the first thing that we're going to want to do inside this container is to do a Git checkout of Studio to get the sources if we haven't mounted them from the host somehow. then I thought we would do an install of Studio already when we're bootstrapping the Docker container, and the reason for that is just to kind of pre-fetch and cache a bunch of stuff, because when you install Studio, it's going to go off and it's going to fetch a lot of Nix packages for kind of all of the software dependencies that we have, and that's going to take some time, of course. And why not just take advantage of the Docker build process here to already pull in, you know, a very recent version of all of the packages into the container, so you already have it when you start, and that way, if you do a completely new installation of Studio, you will still have all of the packages kind of pre-cached in your Nix store. So I'm thinking that line probably speeds up installation time by 90% or something. That's my loose thought. And then we have this expose line to say that we're going to have one TCP port that's relevant in this container, and that's going to be the VNC port. So my thinking is that generally you would start, and we'll build this Dockerfile to get an image, and then you would run a container with that image, and in there you would run Studio in VNC mode, and then you would use Docker to connect the VNC port to your host, and then you would connect with the VNC client. So that's what's going to happen. We do the building here, and the output of this is going to be a Docker image, software image, that includes a base version of Studio. Then we're going to run Studio, or to kind of, let's say, to install Studio, we're going to run that. We're going to start a container with that image. We're going to get the version of Studio that we actually want, which is quite likely going to be a git checkout, and then we're going to run that in VNC mode, and Docker is going to take care of making the VNC port available. Then we're going to run something like Tiger VNC on the same machine to go from the Mac host into the container and get access to the GUI. I think VNC works quite well for that. Just close the distracting window over there for a moment. So what happens if we say Docker build this? If that takes a while, we can take the opportunity to go and look at our base image where we're coming from. But let's just say, Docker, please build that. What will happen? Failed. Okay, Docker is not running. Well, let's start Docker. And I guess it's worth revisiting the whole idea of Docker here, which might seem a bit random. The thing that we really want to do here is run a Linux application on a Mac. So what's the simplest way to run a Linux application on a Mac? We could use VirtualBox. We could use you know, like VMware for Mac or whatever. And I was just thinking the easiest way is probably Docker. Because Docker, they put a lot of work. I mean, Docker is extremely optimized for convenience, and basically the thing that it does is get you a Linux VM with your user space of choice very, very conveniently on a Mac, and I guess it works fine on Windows and stuff as well. So I think that this seems like a reasonable choice, even though, you know, anything would work. So do we have Docker running now? No. Well, then of course we have to also realize that Docker is then another moving part and a dependency. So if for whatever reason Docker is not working nicely on a particular machine, then that's going to be a challenge. So let's see what's going on here. Docker should be running. I have an icon for it there. Docker is running. You can't quite see that, but Docker claims to be running. There's a button I can use to restart it, but before we do that, we'll say something. Unable to upgrade to HTTP. I don't know what that means. So Docker offered to do an update, and I said no, do that another time, but maybe that was a mistake. So let's let Docker update itself, and we hope that this is not like something that's going to happen all the time. We'll get Docker to update itself, and while it does that, we will look at the base image that we have. Alright, so that's happening. And meanwhile, let's hop over. Let us hop over to find the base image definition that we're using. So I don't actually use Docker very much, and the main reason I think is that there's a lot of overlap between Nix and Docker. And for my purposes, I tend to use Nix for most of the things that they can both do, because Docker is a bit more optimized, focused on deployment and convenience, I would say, while Nix is a bit more focused on kind of development and reproducibility. And for my purposes, most of the stuff that I'm doing is I'm more sensitive to reproducibility and kind of productive development, and less so about deployment. So that's why I kind of don't trot out Docker very often. But to deploy a Linux application on a Mac seems to be the place to go. Nixos on Docker Hub. Okay, so this is a bit indirect, right? We have something here that starts from another Nix image that we want to probably look at. And then what does it do? It updates. It adds the latest unstable package repository and pulls an update. So this is kind of like apt-get update, and it makes sure Python is installed. That seems a little bit random to me. Hang on, is this? That's the Nixos/Nix. So is it bootstrapping here? And this says Nixos/Nix, and this also says Nixos/Nix. So is this suggesting that this version bootstraps from a previous version of the same package? And if so, how do we get that version? Look at tags 1.11, shall we say? I can't see. I'd like to see the Dockerfile for that 1.11. Hang on. Sorry, this is just a description. Here's the actual Dockerfile. Let's do that. See if it's the same story. Okay, no, that looks a bit more from scratch. I don't know if this agrees with the comment that we just read. It starts from Alpine. It gets OpenSSL, and that is so that it can download the Nix installer of HTTPS, and then it does a bunch of mucking around to install Nix itself, and it sets some relevant environment variables, and that's it. So okay, so this is what we get here is basically Alpine Linux with Nix added in some hopefully good way, which should be completely fine for our purposes. Now, what's going on? Docker is still updating itself. Install and relaunch. Installing and relaunching. Dependencies, dependencies, dependencies. Updating again, are we? So I mean, we're doing a little bit of kind of busy work here, but I don't think we're anything close to the level of manual work we would have to do if we were going to do things with VirtualBox or something like that. We shall persevere. Docker is starting now. Should we report this thing as well? So we see the Dockerfile there, but when you actually pull up the page, sorry, now I understand. This is this is suggested usage for how, this is an example of how you would use this image. I'd been kind of imagining that was a summary of the Dockerfile. This is saying, no, if you want to actually use the Nix image, you could refer to it like that. You could make sure you have the latest packages of everything, and you could install a lot of a full batteries included Python like that. Okay, then that makes perfect sense in that case. Good. Has Docker started yet? No, it still says Docker is starting. Okay, and we give it another few minutes. While that happens, we can see if there's any next step we could start to ponder. So we have our stuff here. So one question is going to be, when you run Studio using Docker, which version of Studio is it going to be? And what I've tried to do on Linux is to always be running out of a Git checkout. So you don't kind of do a separate installation and run. You rather do a checkout and you run from that. And if you change something, it goes instantly live. And if you want to hop to another branch, you already have them all there, and it's really nice. So it'd be neat to do that again. So I'm thinking, even though we're kind of installing Studio in the Docker image, the way we would actually run it is to have a Git checkout and to run the bin Studio script from there. And we could either check that out from inside the container if we want to, or we could, with Docker, we could mount a directory from the host file system. That's another actually really convenient thing with Docker, is that it makes it trivially easy to share a folder between the host and the container, which could be a nice way if you want to use Emacs on the host, or whatever, to edit the Studio sources and then run that into the container, and also be able to nuke the container without losing any of your precious source code. As a thought. Okay, Docker says that it is running now. So let's see. Docker status. Is there such a command? Nope. Okay, if we try Docker build again now. Now what happens? Will it at least attempt? Yeah. Okay. Something is happening. It's getting the base Nix source image. And I would imagine that this is a pretty efficient way to do that. Like Nix fetches packages one at a time. Well, not one at a time. It does them in parallel, but it fetches individual packets, with some level of parallelization. And I think, I would imagine, to just in terms of raw throughput, the Docker approach is probably quite nice, since it's fetching whole contiguous images. So everything, well, hard to say. I guess with enough parallelism, they should both be equivalent. But anyway. This is just taking a while because it's the first time that I reference the Nixos image on this machine. Now it's using Nix to install Git, because we want to have Git available, because maybe the first thing that we're going to want to do inside the container is do a Git checkout of Studio. So this is basically just installing some random command, and we could do this with Alpine Linux instead. I did it with Nix, since in this image we have Nix installed, and we're going to use it for other things anyway. I'll type briefly in the live chat. Generally, I don't manage to keep an eye on the chat while I'm going, but I guess it's nice if there's a few people chatting along there. It's always very nice. Anyway, okay, so now Nix is installing stuff. Did we have any? Let's check now. Did we have any parallelism in that script? I'm wondering, because when Nix fetches things, this kind of looks like it's happening one at a time, and getting things one at a time is nice in the sense that it keeps the output readable, but it's not as nice in the sense that it takes a longer time, since you need to keep stopping and starting and warming up and everything. So I'm going to get the new tab for the shell, and we will consider. Look at the command. We might want to add some parallelism. Maybe we'll put that in later. This is all time that you would have to spend as a user. This is time you'd have to spend waiting when you installed Studio, if it was the very first time you'd kind of installed Nix. You know, because Nix, every piece of software that Nix wants to use, if you know, here we see Perl and libreadline and all kinds of things, it always fetches the Nix binary, or you know, the Nix version of that package. It never uses what's on the host. So the first time you do anything with Nix, of course, it takes quite a while to download stuff, and this just makes me see some value with Docker, that we're doing this in order to bake it into the Docker image. So when you would pull the Docker image, then all of this work would already have been done. You wouldn't have to wait like this. It's only when you're building the image, not when you're using it. And for the sake of building quickly, I really should have, you know, run about 10 parallel downloads. Question is whether it's worth interrupting that, or whether we just wait. I think we're going to interrupt it. I'm becoming impatient. We'll do a race. If we can finish before we update the file, then it can keep running. But I think the parallelism will make it run much faster. So if we hop into Git Studio Dockerfile, so the way that I normally do this is just actually like this, to just pick a random number, say 10, for the number of parallel builds or downloads that I want to run, and that should be, you know, somewhere around the sweet spot for getting things installed quickly. So did it finish already, or is it going to get an interrupt? It finished already. Okay. Funny then, so that already finished, and so since we're using Docker, we might want to actually, for the moment at least, take that back, because you know, Docker will cache these things. When we do Docker build, it goes through these sequentially, and it's only when it finds something different that it actually runs the command. You know, so that work has already been cached. So even when we're developing interactively with Docker now, that's going to be reused, unless we change this, in which case it's got to be done again. So we'll do that at an opportune time. Okay, so now it's installing the master branch version of Studio, and the reason it's doing that installation, as I said earlier, is really just to make sure that our Nix store has most of the packages that we're going to need already there. Like, it's got Tiger VNC, it's got RaptorJIT, it's got like Pharaoh Smalltalk, all this kind of stuff. So these are not necessarily the exact versions that we're going to want for the version of Studio that we want to run, but a lot of it, I mean, a lot of these packages we see here will be the same, and yeah, that'll be time that we save later. We spend time now while we're building the image, and that means people won't have to wait that time when they're getting up and running. I wonder. No, I guess the whole idea here is to do it on a Mac. I guess we could do it on Linux first, and then we could run it like on a server with a gig internet connection that might speed things up. But I don't know. I have a pretty fast connection here as well, actually. So what are we going to do when that finally completes? Then the next step is going to be to actually install Studio. So let's just check what our installation steps are. So the way that we say to install Nix, but we would skip that step because we already have it. We would say to fetch Studio from Git, and we do have Studio already installed, but I think that we want to do this because we want the user to know where it's checked out and which version they're running, so that it's really easy to hack on it. We don't want it to be a read-only thing. We want the Studio install to be read-write. Yeah, and then so you can go in and pick a branch or a version you want, and then we're going to run this Studio VNC. Since there will not be any other VNCs running in the container, the first time you run that, it should pick port 5901. Is the first VNC display port number by convention, and that's the one that we asked Docker to expose, so it should be straightforward to get that accessible from the host. So yeah, when all this completes, we're going to run, we'll have our image, we're going to run the container, and then we're going to run these Studio installation commands, and if we see any problems along the way, we're going to sort them out. Pull up our to-do list again and see where we are at. Keep ourselves up to date. Here we have our draft Docker file. Now we're building a Docker image, so that's where we are. So let's update our little blue goal at the bottom of the screen. How's that going? Oh dear, I should have used the -J from the beginning, hey, but if we need to make any changes, then we're going to do that. Otherwise, we'll let that go for a minute. I don't really know any way that we can get ahead of this. We really need to get this this Linux environment up and running before we can do an installation. So we're just going to have to eat this up. In the latest version of Nix, they actually have a kind of grand integrated progress bar that shows everything happening in parallel and all that kind of thing. It's going to be quite nice when that gets released. Nix 1.12, I believe it is. All new command line interface and everything. Okay, but now we're at the point of installing RaptorJIT, and that's going to be a build dependency for RaptorJIT. So we're getting quite far out the kind of dependency graph, I would imagine. So I guess this is emphasizing in my mind the importance of streamlining the installation process a little bit. So if I would ask somebody to go install Studio, say, hey, there's this great program called Studio, you should check it out. If their experience would be to sit and wait like this for so long, that's not so good. So I've got to make sure that, well, that's a serious thing actually. So let's put in some parallelization, because we actually need to be making sure that users never are in this position of waiting such a long time for stuff to come down. So actually that's not cool. So I'm going to, at the expense of possibly more or possibly less time now, I'm going to parallelize all of this stuff so that we keep our feet on the ground. We know how long things take. And we might even go a bit crazy, shall we? We'll be generous with the level of parallelism, because we won't always be using all the available network bandwidth. So let's see, let's try this out. So this is going to unfortunately repeat all of the work we just did, but hopefully it's going to run like 10 times as fast, and hopefully it's going to really just burn through. Let's have a look. It's going to be spewing a lot of output because this version of Nix just kind of lets all of those curl processes run in parallel. So now it's running, installing Git with 15 jobs of parallelism, which could either be compilation, make builds, or it can be downloads from a cache. In our case, we're getting everything basically from a cache. I did, in any case, the base image that was already cached in Docker. And this is getting rebuilt because I changed the argument there. It's a kind of an interesting thing about Docker. It's very optimized for convenience, right? Like, there's no guarantee that we're getting the same thing every time we run this, and so there's no guarantee that using or not using a cached version actually what the impact of that is, whether it's a big deal or anything. And this is kind of why I stay a little bit clear of Docker. There might be some nice tools and workflows and add-ons and stuff to keep track of that in serious production environments and everything. But I love it for the convenience when that's the thing that's most important to me. Okay, so now it's installing Git. Got a lot of packages to get. I guess it would be nice if this would be cached somewhere as well, right? Like here we already. This is the kind of time you'd like to have a squid proxy or something, right? Because we already transferred all of these files from the internet to our host just a moment ago. It's just that, and we also cached them. We just didn't cache them in any way that they're accessible from one run to the next. That's something I could think about. How to get a quicker development workflow with this stuff. But anyway, hopefully that's actually downloading much faster. It took probably took 5 minutes or something before. I'm hoping this will only take about 1 minute. There's the Git package, what we ultimately wanted. Okay, I mean, so that's a lot better. So if you tell people it's going to take a little while and they sit there and wait 1 or 2 minutes like that, then that's not gonna kill anybody. So then I guess what we're seeing now is the experience when you install Studio on a Linux machine that didn't previously have Nix, because that's what we're doing, right? Right now we have a base Linux image, we put Nix on it, and then we installed some first packages from the Nix universe, which takes a little while. And then we're going to install the Studio packages as well. And that's what we're doing now. So it repeats. That installation of Git is now like a layer of the Docker image, and now we're adding another layer which installs the Studio packages. And this is the step that I interrupted it just now because it was taking too long. So I'm hoping that this will run much faster now. The J15. Yes, this is of course a bit not really worth measuring. It's very peculiar to a particular machine and internet connection, how much parallelism is appropriate. So here we go. I'm fetching a lot of packages. The output is kind of nasty, but at least it gives the sense that progress is being made on more than one thing. It's probably all that we really need to know. I suppose I should buy a joke book or something. Then I could fill in these awkward waiting on build silences. So what's going in now? A lot of X libraries. I'm just trying to get a feel for how far up the dependency graph we're going. N cursors, that's a pretty basic thing. LLVM, patch elf. Hoping to see in the scrolling something that we really recognize as a part of our application, so we know we're getting the basic dependencies out of the way and up to the more significant stuff. Readline is not. Very basic. Systemd, SQLite, that stuff is all super duper basic stuff. Rat poison, that's something we recognize anyway. That's something that is installed for Studio for running the VNC setup. So that gives the impression that we're getting closer to the end. So there's a lot of generic stuff. I'll just let that do its thing for a little while. This actually kind of ties back into something we worked on last week, which was being able to inspect the Nix store to see the progress of builds. So I'm thinking of that in the context of doing things in the Studio UI, but it's something that I would like to have in Nix in general. When you fire off a build, to know what is everything that needs to be built or fetched, and what is the status of each of those things. Is it something that we're waiting for dependencies to be resolved or capacity, or is it something that we're currently downloading or building, or is it something that we already have downloaded and built, so that you get a feeling for the overall status? You're a bit lost at sea when you're just looking at it like this. You see a lot of stuff scrolling, but until you get to really kind of recognizable stuff, you don't know. So at least I'm starting to see actual Studio stuff getting built. Although that it's hard, it's a little bit hard to try and infer the progress just from the names of things that are building, because I don't know exactly how they're being scheduled, and I suppose a lot of the things we build don't have much in the way of dependencies, so they could be fetched at any time. It's looking more promising. So now it's all Pharaoh and RaptorJIT and that kind of stuff, and that's all stuff that's in hours. So that actually looks quite promising. Pyro font config, that's all Pharaoh stuff. VNC, that's also some of our stuff. I'm curious as well. I think some stuff is actually going to have to be compiled, and that's another thing we've looked at other times but not resolved yet. We don't want anything to get compiled when we're doing this step. Okay, again, what we're doing now is building the Docker image, so actually all of the downloading and building and everything work that gets done here would actually be skipped if you would install this this image as the base to run Studio from. So in some sense, it's going to be offloading all of this work from users when you install it. But in a more general sense, I would like to avoid the situation where Nix ever needs to build anything, and that the issue is that some of the software packages we use are not upstream in Nix packages, and we actually have binaries of those on a Nix binary cache, but we haven't managed to find the right setup so that they can be used, because there's kind of because Nix has trust issues with which caches it's willing to take packages from. By default, it's only the upstream Nix binary cache. We need to add another one there. Okay, so now what's going on? It's getting so now it's building the RaptorJIT virtual machine, so that's quite something far along. And again, the reason it's doing this is just so that we already have it built in the Docker image, so that when we run, this will already be there. Now it looks like it's building the Pharaoh Smalltalk virtual machine. And it's a funny thing, I did a kind of an elaborate packaging of Pharaoh for Nix packages, and I sent that upstream, but then I found upstream a bit hard to deal with, in the sense that everybody upstream is working on the latest unstable version of Nix packages, while I'm working back on the last stable release. So I actually just rewrote the Pharaoh support for myself on the stable release, and we're just using that. So the package has to be built locally, because it's not the same one as upstream. That is a theme on my mind very often lately. How do you, some users of a project want to be on the bleeding edge all of the time, and some users want to be on a stable version. So how do you make it easy for both kind of users to contribute and stay up to date with the upstream project? The projects that I'm contributing to lately, or trying to contribute to, like Nix packages and Pharaoh, are very much geared towards people who are on the very latest bleeding edge all of the time, and it's quite challenging as someone on the stable branches to participate in those communities. So this build now is something that I specifically want to offload onto a binary cache. Now Nix is building a Smalltalk virtual machine, and I just we should be able to optimize that away. And the thing is that when I run Studio, I'm normally running it on a server. I don't know, the server probably has about 12 cores or something like that. So anything that involves things like compiling C programs just kind of blasts straight through. It's probably good for me to actually look at how long it takes to compile things on a normal machine. This is like a dual core Mac Mini. So I mean, this is kind of painful. So I want to. I am reminded of the value of getting the installation process streamlined and not requiring any builds. A lot of warnings. So the virtual machine it's building now, to digress on something relevant and interesting to me anyway, the Smalltalk virtual machine is written in Smalltalk, and that's a kind of a cool idea, right? So basically, if you have a Smalltalk, or you have, well, yeah, a Smalltalk or any programming system really, you have it up and running, and you can just use it to write a virtual machine for itself. There's no reason not to, and then you already have a VM, and then you write another VM running inside that VM, and you can hack it, you can add features, you can do all kinds of things. It doesn't have to be the same. So then you've got your base VM, and you've got your new VM, and the trouble you have with the new VM is it's dependent, right? So you need to have these nested VMs, and then you lose a lot of performance and everything. So the question then is, how do you break that dependency and get the new VM? If you have a Smalltalk VM written in Smalltalk, how do you get that to run without needing without needing this dependency on another Smalltalk to run it. And the solution they came up with is actually really clever. I like it anyway. So what they did was they defined a subset of Smalltalk that is easy to translate into C. This is called slang. So they defined a subset that just doesn't use any of the features that are hard to translate into C. So you can write, when you're programming this slang dialect, you're writing Smalltalk code, it's running in a Smalltalk environment, you're using the Smalltalk debugger, you're using all of your nice high-level tools. But you're programming in a restricted model. You've got to be careful about which language features you use in the actual program. But then when you have something that's ready to run a bit faster, you can press a button. There's an automatic translation of slang code into C. So that's the way that they actually do it, and that's the way that they've been doing it for the last 20 years or something. Is just to write the Smalltalk VM in Smalltalk using a restricted subset, and then to have a translator that translates that into C, which is pretty cool. So like I'm working on the RaptorJIT virtual machine a lot, and that's just written in C. And it's, you know, I don't mind programming in C. C is kind of fine in some ways, but it's certainly pretty impoverished environment compared with some others. So I'm not in the mood to make such large scale changes to a VM, but it would be really cool to be writing it in a really high level language instead of, you know, directly in C, maybe. Wow, that takes a while. I've had the idea with Studio from the beginning that, you know, the basic mental model I have is you would run it on a server. So you would expect to have quite a few cores and plenty of disk space for cache and a fast internet connection for fetching things and everything. And that's a little bit kind of true, and it's also a little bit of a hand wave. Like you certainly want to have the ability to run it locally. The whole thing that we're doing now is making sure that it's reasonably, you know, we're trying to make it convenient to run also locally on a little Mac or something, because maybe you're on an aeroplane or whatever, and you don't have access to a server, or, you know, or maybe you just want to run it locally. But so yeah, I have some optimization to do here, obviously, to make the setup process quicker. Okay, that's gone quite a long way through. Now it's actually building the Smalltalk application. It's got the virtual machine, building the front-end user interface. Building the wrap poison configuration, building the VNC. I think it has now successfully installed all of the packages. So the very long and torturous Docker build step there has finished. And hopefully Docker is then snapshotting the result of that in a new image layer. And then we won't have to run it again until we actually want to change something. It may not help that, to my eternal regret, this Mac Mini has a hard disk rather than an SSD, which might not be at all helping with all of the I/O involved in things like compilation. I don't know what I was thinking. It's very tempting to start doing something else in parallel, but try to keep it simple. Have a relaxing morning. Come on. Well, what's next after this anyway? To-do list. Close reach. Okay, yes. Next we're going to try actually doing the installation. Seeing if anything is broken there. You know, when we do that, we might use a. We already have a studio checkout on the host on the Mac. So when we start the Docker container, I think that we will mount that directory inside the container so that we do all of our editing on the Mac, and then just have that instantly visible on a shared folder inside the Linux VM to run. Taking a really long time. Don't know why. This is presumably now. I don't know whether this is Nix finalizing the installation or perhaps more likely it's Docker creating the file system. Okay, I guess the Docker has to then look at all of the changes that were made on the file system when it ran that Nix command, and somehow turn that into a layer. I'm not sure what the precise format is, but then Docker is going to get like a stack of binary images of what each step in the Dockerfile did. I presume now it's going through and groveling along and trying to find a good canonical representation of everything, of the end result of having installed all that software. I hear the faint sound of a hard disk spinning, so probably if I had an SSD, this would be long since finished. Wow. Takes an awfully long time. I hope that this whole effort is worth it. I think that it is, because if you really had no option except to provide your own Linux machine, which would then have to be a EC2 VM or a machine in the basement, a server, shared server, or a machine at Hetzner or something like that, then I mean that's probably, if you're using Studio all the time, that probably is actually the nicest way to run it, something like that. But I don't think it's nice to be forced to do that, especially if you just want to take it for a spin or do a demo or introduce somebody to the project. Then I think it really is worth being able to just spin it up on a Mac in a quick way. So that's what I'm telling myself, to prevent myself from pressing Control C on this, or hopping over to work on something else in parallel, and then we'll just confuse ourselves. But you know what? Let's take a 5 minute rest and come back, and presumably this will be done by then. But we don't need to sit here staring at the progress meter all the time. So back in a jiffy, hey? So seriously, it's still there. So what's happening is the disk is running around like mad. So Docker is apparently working very hard on snapshotting this, and it just takes ages. Like, am I the only person running a hard disk in the year 2018? It's entirely possible. Entirely possible that's the case. I almost should be doing this development on my laptop with an SSD instead of on my desktop. But ha! Well, okay, that's timing. I was about ready to give up, I gotta say. So now, did we do the ugly part? Let's hope that the next problem is something that involves using our brains rather than just twiddling our thumbs. Okay, so now what's happened is we built our Dockerfile, and what is that? We started from the Nixos base image. We installed Git because we think we're going to need it. We also installed Studio because we just want to have all of those packages there and cached, even though it's not necessarily precisely the version of everything that we're going to use. And we told it to expose port 5901 for VNC. So let's try running that now, shall we? Well, we have a name for the container there. If somebody remembers the Docker command to assign symbolic names, just say that in the chat and I'll do that. But for now, we'll just use the ID. If we would say Docker run I think that's what we want to say if we want to get an interactive shell with the exposed ports automatically bound somewhere. What do you reckon? And let's give this a name. Let's say Studio. Clunk. If we're lucky, this gives us a Linux. Yeah, right. Okay, so now we have a shell. So now we should be in Linux, right? Yes. So we're not on Mac now. We're on Linux. And so since we have Linux, we should be able to run the Studio installer steps. Okay, so let's update our little plan text file here. And let's try doing the installation. Cool. Okay. And I think the first step was say git clone. Hang on. Yeah, we'll do it this way. I had said that we were gonna mount the checkout that we already have inside the container, but for now, actually, we'll make sure that git works as well. Okay, so now we're hoping to get the sources. Looks promising. Okay. And just to make it interesting, we'll switch to another branch, so it's not exactly the same thing that we already installed when we built the container. And if we would, before running the VNC, we'll do the test. So the test command is something we added in an earlier stream, where it just starts the GUI really headless. Aha, we don't have bash. That's interesting. Okay, great. The test command starts a kind of a headless one and takes a screenshot, so we get a file out. So it's basically just a sanity check to see if things are working, and they're not. So we don't have bash. That's interesting. So where is the need for bash coming from? Here. Okay, that's fair enough. So bash is a dependency that we have in Studio that's not declared, I guess. So maybe that's here that we want to. If we open up the Nix file that starts Studio, this bin/studio script that we're running. God, now I'm editing the file in Emacs on the Mac. So this is not the same one that we have in there, but we'll do the reading here anyway. We have this line here that defines the software that we're going to have in the path when we run. Okay, no, but this is even earlier, right? This is this whole script starting. So we're saying we want to run bash there. So this was something I did. I started with bin sh, and then I very quickly got bored of writing even such a small script as this in like strict POSIX Bourne shell. I wanted bash because I think in bash a little bit. But then that's actually a dependency that we have. I think we'll just install bash. It seems like the easiest thing to do, right? So we'll be brave and we'll update our Dockerfile to install bash. But we're going to be really careful, right? So if we would change this line, we could say we put it here or here to install bash. But if we do either of those things, we're going to repeat that step, and we desperately want Docker to cache all of the work that's already done. So we'll do it here to start with, and then at the end we'll kind of think about kind of combining these lines together a little bit. But we'll absolutely avoid that at the moment. So if we and having updated the Dockerfile, we'll also just do it straight here while we're here. So it's actually kind of nice having such a stripped down environment to test in, to find these undeclared dependencies. I had already found that when I was first hacking Studio, I did it just on a development machine where I do a lot of other things, and I had a lot of software in the path, and I found that I was accidentally depending on a lot of that software. And then we did the CI setup to run on a pretty bare Ubuntu on Travis CI, and that flushed out a lot of these problems where there was something we depended on that wasn't kind of tracked. And now in Docker we're getting something a little bit more extreme when even bash is not there, right? You have bash in a fairly bare Ubuntu, so this is actually quite nice to have such a bare environment help us find these problems, because we really should be declaring every single dependency that we have. So I'm cheating a little bit here with bash, I guess, in saying that we are expecting bash to already be available. I wonder if that's okay. I wonder if we could change the script to rerun itself. No, let's not get too fancy. I think it's nice. It's nice to know that we need bash. It's nice to know that we're at the level of stripped downness that we see these kind of things. But I'm not that worried about actually requiring people to have bash installed, because that's a pretty basic thing. But why is this taking time now? Can it be that Nix generally runs like rubbish inside a Docker VM on a Mac with a spinning disk or something like that? Like this shouldn't be taking any time, right? Nix install bash should just be bang and done. I want to know what's going on. Crap. We have a... So I'm gonna look for a way to cheat right now. But it's a bit of a problem if we can't depend on Nix to actually have decent performance inside this little Docker. And the other question is why? I wonder, it's not swapping or something, is it? Like how much memory? Look over here. HyperKit. Around about 2 gigabytes. Here we have 8 gig and plenty free. Okay, so it shouldn't be swapping, so it's some kind of I/O that's happening. Is it APK to install things with Alpine? See if that works better. Does it? Okay, that doesn't look like the way forward. But what a pain. I just want to get bash installed in this container. And I don't understand why this takes basically any time at all. I'm not even really sure how to make sense. Can you profile in any meaningful way a Docker container from the outside? I mean, is this I/O bound, or is this compute bound, or is it just stuck? What is going on? I don't think you get much joy there. Okay, now something is happening. So it seems like it was just wedged somehow before. I don't understand. Okay, now it's installed bash anyway. Fine. Let's try again. Try running the Studio script for a test. Okay, now it did have bash because we installed that manually. And what do we see now? It's installing some packages. So the Docker container includes all the packages that you would need to run the master branch of Studio. This is running the next branch instead, so it kind of looks like there were some different packages that were needed, so it should be just downloading a delta, just the packages that are different, and just doing it the first time. So this, I think that this looks good. We shall see. An error. Is that the real error? This is so we got an error, but this error came from pretty deep, actually. So what it did was it actually looks like it successfully started the Studio GUI in a headless mode, and then that tried to run a Nix script to build like a. It's actually trying to run a Lua program in a virtual machine and get data. So it's actually gone quite far. We didn't see anything because it's headless, but then when we tried to run a build in there, we didn't get. A problem with the SSL certificate authorities. This is some kind of environmental problem or something, right? Like, I think when we looked at the base image, it had done something special here. I wonder if we lost that somewhere. Hold on. I wonder if we need to treat this specially somehow. When the Docker container for Nix was created, it set obviously some of these environment variables, and then we're doing this thing with Nix shell -- pure where we deliberately purge the environment before we run Studio, and that's well intentioned. The idea is that we don't want to accidentally depend on some important environment variable. But maybe this is a case where we do depend on a variable, but we're zeroing it out or something. We might need to actually set those. A little tricky. So for starting off with, let's just try. We're going to live a little. I'm going to get Emacs. What I want to do now is try if we just run everything again, but without purging the environment. Thanks, Hugo, for the cheat tips. I didn't see that in time. I probably map the chat into the video somewhere, so it's always in sight and in mind. At the moment, I only think to look at it every 20 minutes or something, and usually I've missed whatever that was the most important thing. But yeah, what I want to do now is to try running Nix without this pure thing. So we'll inherit the environment from the shell we're running in, and if that works, then we will know that there's something in the environment that's important that is getting stripped out, probably relating to the certificate authority. Again, that's doing serial downloads, but we're going to let it run for a little while like that anyway. We'll have a little bit of a look in our script and see how we might deal with that. So this is where we start a Nix command. We say Nix shell, which is basically going to run bash with an environment and a path and everything set up in a special way to use only the software that we want. And we use these Nix opts, and this is the kind of contentious one there, pure, that's supposed to flush or like sanitize the environment of the shell that we run it in. So that's potentially stripping away some things that we care about. So we want to see whether disabling that. But I can actually safely interrupt this now, because now we're not in the Docker thing. So I'm going to press Control-C, and it's actually not losing anything now, because all those packages are still in our little Nix environment now inside this reusable container. So I'll just continue installing Emacs now with more parallelism. I won't have to repeat any of that stuff, which is nice. Good on you, Nix. So what are we doing? First thing we're going to do is take away the pure, and we're hoping that that will then work, and or at least get us to the next problem. And if it does, then we're going to need to isolate what is it that we're losing from our environment that's important there, and how do we pass it through. And I don't know that. So if we want to be like selectively pure, if we want to use a pure environment except for these variables that we actually care about, how do you do that? Does anybody know that? We'll look in the manual page for Nick's shell. I don't know if we have it here. See if we can whitelist certain environment variables. It's incredible the amount of small things we need to worry about to actually get a smooth installation happening from one machine to the next. I don't know. I was expecting much less. I don't know if that's my own naivety or if the approach that I'm taking with the installation is actually, hard work. I'm not sure about that. Okay, we don't have the next shell man page there. Anyway, we have Emacs now, so we can say we want to edit that file. And for now, we just take away the pure and see if everything works. Clunk. We got an error, but was it the same error? Roll up a little bit. Interesting, permission denied on the temporary directory. We've seen something similar to this in the past, where sometimes we would end up using an unsuitable temporary directory for builds. The thing that we saw before was specifically that somehow we get a build directory that was on a file system that did not allow any executable files, and some of our software needs to actually run code that it builds itself, and that was not allowed. So is there something weird about this? Is in /temp. First, let's just see if there's anything weird about the permissions on /temp, and then if not, then we'll dig in a little bit more specifically there and see what the issue is. Where's the grep? We have a mount point for /temp. Hold on. Sorry, wrong command. Yeah, how do you ask for one specific? Can we give a mount point there? Okay, so is it the case that /temp is not anything special? It's just on the root file system. And if so, anything, there's a lot of options. Overlay file system. Read write. I'm going to try seeing. I want to see if the problem is the temp directory somehow. So what about if we? How do I say this? Yes, I am root. Okay. Let's look closer at what the specific error was. often when we end up digging into these annoying looking errors, we actually find something interesting. So we'll hope it's going to be the same again, and it's going to be worth digging into this. So do we still have that file? No. Hang on, let's see. High level context. What was happening when we were the error? So we ran bin/studio test. Says that it is exercising the studio UI, which means running a kind of a headless version. And inside the GUI, this is actually driven by the GUI now, it's trying to run Lua script in the RaptorJIT VM. And that's going to build some dependencies that were needed. libyaml, Python, this kind of stuff. But that's for post-processing some of the files that are generated. And while we were building the Lua, we're building a Lua script. So basically, I'll pull up the code that does this test and talk about it more sensibly. So here's the, we're saying exercising the Studio UI. It's talking about this code here. This is actually Smalltalk code that is running. The Smalltalk code is going to call out recursively to Nix and say, please run in RaptorJIT this fragment of Lua code. And that Lua code is going to get written out to a .lua text file in order to run, and that's the build step that's failing actually. It's trying to build this Lua script on disk that's just going to contain that tiny little fragment of Lua code, but somehow it's failing with a permission denied error. And is that when this script, which we should actually have on disk, we should be able to look at, is on line 500, it's trying to do something with this. I'm not sure if I'm parsing that error message right. Is it saying that this script on its line 500 had a permissions error while accessing that file? Let's have a look. If we load that script and go to line 500, that looks plausibly like a relevant line. This function is useful for debugging broken Nix builds. Okay, so it's trying to dump environment variables. So it's getting a permission denied error here on a little subroutine that's just trying to log what all the environment variables were. So it runs export. You can see what export does. That just lists all the environment variables in the shell. It's trying to get a dump of all the environment variables and write them to a file called envars in the Nix build directory. Oops, sorry, I have a... Hey, thanks, Hugo. So I'm not sure if that just applies to the mount. So, yeah, right. So, hang on, one thing at a time. So what we're seeing here is, this is probably the first thing that the build script is doing, is to try and make a record of what the environment is like. So it says, write the environment to a file called envars in the build working directory. And if that's failing with a permission error, what it probably means is that the directory that we're building in is completely unsuitable somehow. For example, it's read-only when we need it to be read-write. Because that's just writing to a file, right? So if that fails with a permission error, you would certainly imagine the reason is that it's something is read-only that needs to be read-write. So we can come back and try to look for that a little more specifically. It's also interesting what Hugo just said in the live chat, which is to consider whether we need to be running this Docker container in privileged mode. So I don't even know what that means on a Mac, right? Like on a Linux machine, if you run Docker in privileged mode, it basically means that the outside of the container is running root. Well, you know, the container has root access on the machine. What the hell does Docker? What does it mean when you do Docker privileged on a Mac and you have three levels? You have the Mac, then you have the the hypervisor running the Linux machine, and then you have the container running inside that. So where do you get the privilege? Is it the container getting privileges to the virtual machine, or is it the container getting somehow privileges on the Mac? I don't know. Let's just keep that up our sleeve for the moment. For the moment, let's try and figure out why we would get this permission error. We'll just see again what the path was where we got it. And that path. Okay, so if we would just, what about if we just try doing that same thing in our local shell here? If we write that, the directory might not exist. Hold on, let's make the directory first, and then do that. So it works if we do it here. It works just fine if we do it here from our like outside shell, but it failed when we ran it in Nix. Okay, Hugo's saying that if we run Docker with privileged, then it's going to give the container privileged access to the VM. So probably we would want to do that actually. Okay, so let's actually do that to start with. We'll come back into this. Oh dear, but is this container going to survive if I close it now? I started this with -ti capital P. If I stop it now, let's see, we'll take a chance. What's the command I'm looking for to get back in? Oh, okay. And I don't have a privilege. No, sorry, wrong. Okay, that's a slight bummer if we need to do a little bit more installation stuff here. What a pain. Hold on. Let's revise our Docker command line a bit. I accidentally closed the tab that I was working in. Get a new one. Okay, suppose we run this time in privileged mode. It was a new container based on the same image, so we won't rebuild the image, but a new container in privileged mode. And what else do we want to do? We want to do a bind mount of when we access /studio in the container, we want to see the studio checkout we have on the host, just so that we can do the editing on the outside. Oops, we already have that name used. Actually, in the background, we have our Dockerfile. We know there's some other stuff that we want as well, right? I'm going to build that one so that we have it for later. Was there anything else we already know now that we want while we're debugging? We'll grab strace as well, right? Always nice to have. And separately, without waiting, we'll build that. Just make sure that it starts okay. Yes, good. Okay, we have that for later now. Meanwhile, we should have now we're inside a new container that we just started. If we look in /studio, we should see, yes, that's a folder that's shared with the Mac into the container here. let's just reproduce that problem. Okay, there's the problem with bash not being there. All that. Sometimes takes a long time. I guess the thing to keep in mind here is that Docker is a bit like it's a non-trivial kind of runtime model and everything. So the end result that we're hoping to get to here is that the user doesn't actually have to care about anything. You know, the user actually just wants to just copy and paste a command, which may or may not start with Docker, and get the application up and running, you know, on a local Linux environment. And so I don't want people to really have to be thinking about like naming containers and running versus starting versus attaching and all of that kind of thing. Like, of course, if you're a Docker person, you should be able to do all that, but we're really hoping that we're going to get this into a state where it's kind of trivial to get things up and running and that you don't need to worry about Docker workflows and all of that kind of thing. Comes our bash. And now we're waiting to install bash, but next time we're not going to wait because we're building a container that has more useful software baked in. Okay, now let's try reproducing our problem again. And this is running in the Unix environment, I suppose. We're running the studio script from the checkout on the host, which is this one. That still has the ---- pure. So this is a pristine copy of studio. See what happens. Okay, so that's starting Studio, and it's downloading the specific packages for the specific version of Studio represented that we've got checked out with Git. Is fine. Sorry, and now Docker build over here is in that same bit where it seems to have finished doing the Nix install, and now it's creating the image for the layer. And that's going to take a long time, but we don't care because we're working over here. Okay, so now we got that same error that we saw in the beginning with the SSL certificate path. We kind of got two different errors, right? If we run with the pure environment, we get the SSL certificate path problem. And if we run without the pure environment, then we get another problem with the temp directory being wrong. And that's something that we've seen before, and we actually have a special thing. Sorry, we have... Yeah, okay, so we actually have in this script here, we explicitly get the temporary directory by calling make temp, and that actually might be... Can that be kind of forcing... Might be switching from a working temp directory to a non-working temp directory. Like if we just look over here, what is our temporary directory? Is anything set in the environment? Yeah, no, so it seems like /temp is the... See any references to temp directories that are being used? Yeah, not immediately, they're all store paths. Okay, anyway. Which problem do we want to fix? Do we want to fix the problem with the SSL certificates that we get with the pure environment, or do we want to fix the temp directory thing? I think we want to fix actually the SSL certificates one because we want to run with the pure environment. So let's actually Google this and see if this is a known problem somehow involving ways that you use Nix shell. Okay, well, it looks like I've already visited this page recently. Sounds promising. Your shell will not have these. Okay, so I think we want to pass through. We know that these variables are important. I don't want to. Hugo says we could ask Nix to install the CA certificates. Is the name is CA certificates the name of a CA certificates the name of a Nix package? Let's try that. Thank you very much, Hugo. Wow, so this is like part of the, kind of the fantasy live streaming workflow, right? The idea that you start working on something, you're using some tools, Docker, Nix, Pharaoh, that there's other people who understand much better than you do, and you can actually get people saying like, "Hey, what are you doing? You're doing that all wrong." This is kind of like a fantastic idea. Thank you very much for taking the time to help me out here. This is lovely. Okay, Alpines. Wait, can we install the CA certs with Nix instead? Inside the Nix shell? I'm going to try that. I'll see if there's an asynchronous message. There's a tiny bit of lag with this live stream, so I can't always synchronously get respond to things. Okay, we're gonna ask Nix to install the CA certificates. Okay, but first we'll read this. It's a duplicate of that. Maybe that also gives us something we can copy and paste. We want to just make sure that the certificates are installed. CA cert, is that okay? It looks like there's a package called CA cert that we might need. So the thing is, when we run Studio, we have this this thing here saying all the dependencies that we have, and I'm going to put bash there because we needed it earlier. We're going to need that inside here as well, and I'm going to say CA cert. Let's see if that does a better job now. It's going to do just the same thing, but this pure sanitized environment that runs everything in should now include CA certificates and should also include bash. I don't know if that's strictly needed, but it doesn't seem like it hurts. Okay, good. It's downloading CA cert, so that was the right name from the package apparently. We still have now same error. Interesting. So maybe it's the maybe we still need to pass through that environment variable value as well. Let's have a look at that issue again and see. What are they concluding here? Who knew this would be so complicated? I scroll down and see any kind of a resolution. Yeah, it might be looking. It's probably looking in the wrong path somehow. We've got the file, we just don't know where it is. Aha, okay. But maybe it's okay to hard code in the sense that if we are if we're installing a known set of certificates with this and they're going to go at a known path, then maybe we can just set wildly satisfying though, is it? It certainly seems to me like maybe we can find the answer on that issue. It certainly seems that if we've installed the Nix package for CA certificates, then when Nix is fetching something from binary cache, it should be looking in the same path, you know, where those go. It seems kind of inconceivable that it would be otherwise, right? Although maybe... You know, we're running Nix recursively here, actually, so maybe we're just not putting that in the right place. The thing is that what's actually happening when we run this command, first we run this Nix shell to get a pristine environment, then that runs the GUI in a virtual machine, and then the GUI actually calls out the Nix build to do some more stuff. Sorry, pardon the bright sunlight there. Get the really bright sunlight on the control. Yeah, so actually, it might be somewhere else that we're lacking the CA certificate. So then, I don't know if that's any more satisfying though. So if inside this Nix shell we then run Nix build, we want Nix build to be able to find the CA certificates, of course. Oops. Yes, all of these recursive environments are very tricky. Let's have a look at the error again to keep our feet on the ground. So this is from a Nix build process that's running underneath. So we run Nix build inside Nix shell. We've installed the CA cert package with that Nix shell. Nix build is not seeing. That seems weird. Okay, let's read this issue again a little bit more and see if there's any extra detail we should be knowing about. Okay, so someone says that this hacky thing helped. Is that something we should do? That's dealing with Git specifically. So is this a Git? Is this when we're trying to grab something over Git? No. This is when we're trying to fetch something from Nix binary cache. There's nothing to do with Git. Presumably using curl behind the scenes. I'll hop over to that issue as well and see if that is something. A lot of hopping around here. I'm not completely happy about this. So let's see the Nix Shellman page briefly and just see if we can. If we can get those variables passed through in some good way, and if that would help anything. Viewer is gonna zap some things. Yikes. So Nix Pure still takes you bash RC? I didn't realize that. That seems a bit... Maybe this is kind of the issue, right? Maybe if we go back to that Nix, if we go back to that Docker container that we started from here, it is setting all of these environment variables like it's very likely that's the thing that we've lost somehow. It's asking Docker to set those in the environment, but how does Docker set those? And how is Nix supposed to get them? So it seems like Nix shell is expecting that any important stuff like this would be either in etc bash rc or the user's local bash rc. I'm still slightly uncomfortable that we're sourcing a user's bash rc in our supposedly pristine environment. I'm not sure if that's quite right, but that's not our fight right now. But anyway, it might be that Docker is putting this stuff somewhere else. So let's see. In either of those places that Nix looks, do we have what we need? No. Okay, so if Nix shell is going to source those places for the new environment, it's not going to get the things that we need. So maybe we need to get the Docker image to set those. Hang on, let's just see if we did have an etc bash rc containing that. Sorry. Then would it work? So now we've got a file called etc bash rc. It sets the path to the certificate. So if we try this again, Is it going to work? If so, then maybe we just need to update the Docker image to set that. And then we got to think, because we don't want this to only work in Docker, right? We've got to also think about whether this is a problem that we're going to see in other environments. But maybe not, because we have this funny business where the Dockerfile has set this variable somehow, and that somehow doesn't seem to be compatible with Nix shell. Okay, but it's merged because we still get the same problem. Alright, I don't want to keep fighting it like this. I think I want to come back to this and write it up as an issue very clearly somewhere and try to get some feedback. I think we're going to put down tools and have lunch now. The problem that we have is that when we run Nix build inside Nix shell, in a Docker image based on the Nixos reference Docker image, that it can't find the SSL certificates, and that means it can't get packages from the binary cache, and that means the builds fail. So that's going to be an issue that we're going to have to open in some appropriate place, and hopefully someone who has seen this before can point us in the right direction. Otherwise, hopefully it's helpful for other people as well who want to get Nix working in exotic ways inside Docker containers. Thanks very much, Hugo, especially very much for the Nix tips. That was actually fantastic to actually get expert help. That certainly is a great thing for the live streaming concept. Thanks, and I'm going to have lunch. Bon appetit.